All right, so that's great when we have situations where I have two lines that intersect. But what happens if I'm given two systems to solve and I end up with something that's parallel? So let's look at a situation where this occurs and figure out how do we deal with this. So again, we're having to graph these. We're solving by graphing. So I have this system here. I'm going to choose to make my first one red just so you guys can really see what I'm doing. Remember, I always start with my y-intersection first. So I find my positive 1. And then my slope is -2. So that means I'm going to go up 2 and 1 to the left. Or maybe I go down 2 and 1 to the right. Remember that if you have a negative slope, it's the same as -2 over +1 or +2 over a -1. All right, so I'm going to do that again. I'm going to go down 2 and over 1. And I'm going to come up 2 and over 1. And now I need to draw my line. So I have something that generally looks like this. Now I'm going to take my blue and I'm going to do my second equation in my system. So again, I'm going to start at my y-intersection point here, which is -1. And I'm going to do the same thing. I'm going to go down 2 and over 1. And down 2 and over 1, or up 2 and over 1, up 2 and over 1. All right, what do you notice about these lines? Well, hopefully as I'm graphing this, you're realizing, oh my goodness, these are parallel. Remember parallel ones, think railroad tracks, okay? Railroad tracks go side by side. They can be horizontal, they can be vertical, or, as in this case, they can be diagonal. But whenever I have parallel lines, they do not intersect. At no point will these lines ever intersect. So what does that tell me about solving this system that I've got here with these two equations? How can I find a solution? Well, there is none. There is no solution. Remember that a 0 with a line through it means null, void. There is no such thing. It doesn't exist. So there is literally no solution to this. Now, how can you tell without graphing if a system has no solution? How would you know just by simply looking up here at my formula and not having a graph that something has no solution? Well, remember that if my slopes are the same, if my m value is the same, but the y-intersection points are different, then there is no solution because they will be parallel. One more time. If the m value or slope is the same for both of my systems, even if the y-intercepts aren't the same, then the lines will be parallel and you have no solution. Make sure you have this written down and you have this example. All right, let's look at another bizarre scenario. Let's say you're given a situation that looks like this. 2x plus 4y equals 8 is the first equation, and the second equation in my system is y equals -1/2 x plus 2. Well, they're not in the same formula, so if I want to solve them by graphing, I need to find what? Well, I need to find my y-intercept. So let's see what we can do for 2x plus 4y equals 8. If I'm first finding my y-intercept, then I need the place where my x is 0 to figure out what my y equals. So I need to plug this 0 in for my x in this equation. Remember that you want to get the points where my x is 0 to be able to start plotting my points. So here I know that 4y equals 8, so my y equals 2 when my x equals 0. So I'm going to make a note of that over here. Okay, this is interesting. They have the exact same intersection point. All right, let's plot my first one in red. So 0 and 2 is right here. Now I have to figure out my slope. Well, in order to figure out my slope for this equation, I'm going to end up having to put it into that slope-intercept form. So I need to take my 2x plus 4y equals 8, and I need to solve for y. So I'm going to subtract 2x from both sides, and I'm going to get 4y equals 8 minus 2x, and then I have to divide every term by 4, which is beside my y, so I get y equals 2 minus 1/2 x. That looks a little bit better, but it's still not quite right. So this is the same as negative 1/2 x plus 2. All I did here was take this guy that's positive and move him over here, so it's in the right form. Now looking at that, y equals negative 1/2 x plus 2. What do you notice about my second equation and this equation? They are the exact same thing. So notice my slope is negative 1/2. So I'm going to go up 1 and 2 to the left, or I'm going to go down 1 and 2 to the right. I'm going to do that a couple of times each. And I need to draw my line. I'm just going to kind of sketch it right here. Okay. Then I'm going to go and I'm going to look at this, and it has the exact same point. And I go down and over and down and over, up and over and up and over, and it is the exact same formula. Oh my goodness. What do I do? In this case, every solution that they have is the same. There's an infinite number of ordered pairs. Every x and y intersect. Every point's going to be an intersection. So there is an infinite number of solutions. This is a new math term for you, I'm sure. When you have a sideways 8 like this is the sign for infinity. So just like this was the sign for none, this is the sign for like all our solutions. So in this case, where you have the exact same equations in your system, you have an infinite number of solutions. Kind of cool. All right, I'm going to give you 2 that I want you to solve by graphing. I would like you to solve these 3 by graphing on your own paper. Make sure that you show me your work, you show me your graphs. I don't mind if you use all 3 on one graph, but if you do so, make sure that they are labeled so that this is one color, this is a different color, and this is a third color. If you do not wish to use color, then please use separate graphs. I hope this helped and this is making sense. If it doesn't and you're curious about how to do these for the first and second one that's on this video, go back, copy these problems down, and go back and re-watch the video using this as your guide. Or if you're struggling with problem number 3, please go back to the previous video and re-watch that one using this set of equations. Notice my little squigglies here. If you're wondering what these are, these just tell me I have a system that I'm working with. All right, thank you and have a fantastic